Welcome to July. Thank you for joining us. It's lovely to see everybody again. Feel free to take yourself off mute to say hi. Put yourself on video, say hi, give us a wave. We'll stick around a little bit after the talk to socialize and chat. We can do breakout sessions depending on how many people are around. If it gets really busy, we can do breakouts. But with that, I want to introduce myself and our speaker for the day. My story is easy. I run a consulting company. I focus on value streams, so flow, performance, specifically in software delivery. And I've been doing that a couple of years now. And we're lucky enough to have from JFrog Baruch with us. And I'll leave your introduction to yourself, sir. You can say a couple words about who you are and what you're about.
Yeah, so thank you so much for having me, Steve. Yeah, I'm Baruch, working for JFrog. I have a proper introduction somewhere in my slides. I will first try to make it interesting for you and then go to talk about myself. What I wanted to say is that hopefully once we're all over this, I will be able to come once again in person, just because I love the city and we'll be more than happy to visit, hopefully in summer month. Although I did most of my roadshow on the cloud native meetups during the winter in February. I did Ottawa, Quebec City, Toronto, Montreal, and Kitchener all in 1 week in February. That was a lot of snow.
That is a lot of snow, yeah.
Living most of my life in countries or states when snow does not exist, that was a hell of an experience. So I really hope I will be able to come in person as soon as it allows, if you will have me.
Of course, yeah, that would be great. And yeah, it's not so bad when it's tough weather, but you want to be in it under the right circumstances. You want to be warm with some good food and, hopefully not have to shovel snow or slide around on the sidewalk.
Yep.
So with that, I really just want to, I don't have a lot going on. I want to remind everybody that, we've got our Slack team, which is always running 24/7. And there's a ton of really smart and wonderful people in there. So if you haven't taken a look at devopsto.slack.com in a while, jump in there, bring your biggest challenges, your biggest questions, your big wins, and anything that you're curious about, and we would love to talk with you. So feel free to jump in there. And with that, that's really all I have to kick things off. I will throw to Ari, who is our sponsor contact from JFrog, who's lovely enough to be sponsoring the meetup for the next little while. And they've been wonderful enough to bring us Baruch. So I really appreciate having them along, but I will let Ari take the show and let us know what JFrog is about and what they're up to.
Sure, absolutely. Well, just wanted to say thank you for allowing us into your community at this time. And like Baruch said, we'd love to get there and be part of seeing everybody in person. But JFrog, we actually have our roots in the community. Before we were even a company, Artifactory, which I'm sure many here are familiar with, came out in 2006 in the OSS version. And JFrog was established in 2008, even before the term DevOps was coined. So we have our roots in the community, and it's always a really, really important part of of focus from everyone throughout the organization. Community happiness is believe it or not, one of our core values. So one of the things we want to do today to make everybody happy is we have a monthly drawing every month, especially during these quarantine times when normally you go to a meetup and there'd be some swag on the table, but Today, we have a monthly drawing at the end of July. We're actually going to give away a Nintendo Switch. Yes, I found one at a Walmart, and then I sent my wife in to buy the other one because they wouldn't sell me two. So that's up for a raffle for the end of July. But anybody that enters the raffle, and Baruch's going to show you a link later for his show notes page, and that has a lot of other valuable and probably more valuable information for you day to day. So he'll go over that with you with the slides and the video and so forth. But anyone that enters that is going to get a JFrog t-shirt. In fact, I am modeling it today. It's the Iron Frog shirt. If you have it, when I reach out to you via email, you just tell me you want another one and I'll figure something out for you. But again, thanks for allowing us to be sponsors in the community. We really, really love it. And looking forward to, this is one of my favorite talks. So I'm looking forward to listening to it again. Thanks, Steve.
Awesome. Thank you very much. And it's great to have you. I think that, you know, one of the things that's so wonderful about the DevOps community is how sponsorship works. Like there's just so much goodwill and positivity shared by the community. And so we love having you around. It really helps us out. And it's great to have access to the talent, the perspectives from inside the industry and across all these different areas that we look at. So with that, I will throw to Baruch and you can take over from here.
All right. Thank you. Thank you, Aris. Thank you, Steve. Let's dive into it. So today we're going to talk about continuous updates. What is it, how to do it, and most of the talk on how not to do it. First of all, before we start into patterns, and I will share with you some horror stories, the first question is why we update software at all. Obviously, there is some software that doesn't require updating at all. So BC, some of you might know, it's a shell, a command line calculator that wasn't updated for 20 years. And that's because there is nothing much to update. Bash didn't change, your shell didn't change, basic rules of math didn't change. There is nothing to do here. Obviously, that's not the case for the majority of the software. The majority of the software, we as users, we want one thing. We want new features. And we want new features, obviously, now. And you can think about how the world of us demanding features changed, comparing the tools that you had 10 and 20 years ago with what you have now. And think about your phone, for example, that you had the first smartphone or cell phone that wasn't smart. You didn't expect it to be updating. But today, if you don't have the bunch of apps that getting updated every day, you are so behind. And this is so true for everything. And our expectations from software skyrocketed. Think about another example, your bank. What were your expectations from a website of a bank or an app of a bank 20 or 10 years ago? Well, it's good if it does something. Today, you will probably switch bank over a mobile app that is not giving you enough features that you want. So this is on us. We want more features. We want them faster. Another very, very important reason is security. And as everything is now software, as we just spoke, security vulnerabilities are one of the major threats that we face today. And security vulnerabilities are basically, or battling security vulnerabilities are basically comprised of three actions. You need to realize that you have been breached, you need to fix the breach, and then again, you need to deploy, to update the software as fast as possible with the fix. So security vulnerabilities is another very, very significant drive for adoption of faster continuous updates. Think about it. If you don't know, even if you don't have to provide any features and you don't know how to update because you never needed it, if there is a security breach, you are in big trouble because you don't know how to update faster. So this skill of updating faster is actually here to stay. And for those two reasons, those are evolutionary pressure that is put on us in order to do that. And we can see that, that the industry response, if we look at the State of DevOps report, and this is obviously one of the most important documents in our DevOps community, this is the research that previously the DevOps Research and Assessment Institute, and then at the research department of Google Cloud. And now, frankly, I'm not sure what is going to happen with State of DevOps report when Nicole Forsgren left to GitHub. It's an interesting question. Anyway, 2019 is the last that we have. And what we see there, that if we break the people that took the organizations or the teams that took the survey to cohorts, you can see that 20% of the industry is what they call elite performers. And what those elite performers do, they know how to update faster. They deploy multiple times a day. Well, actually, they deploy on demand. When there is a new feature, boom, we can take it to production. When there is a security fix, boom, we can take it to production immediately. And this is what required. 20% of the industry, every fifth organization already does it. And every fifth organization already does it because it's not a new idea. If you look back 22 years ago now, 1998, Extreme Programming advocated for short feedback. Scrum 2000 advocated for reducing cycle time. Toyota Production System advocates for deliver as fast as possible. Kanban, incremental change. All of them actually advocated for updating faster. And after 20 years of those ideas, a big chunk of the industry adopted it, but not enough. If you look at the flip side, 80% are not there yet. So, as I mentioned, my name is Baruch Sadorgursky. I'm the Chief Sticker Officer. I bring stickers to the meetups in person. Another reason to invite me once all this is over. And also head of Developer and DevOps Advocacy in JFrog. The most important part on this slide is my Twitter handle, @jbaruch. It's the easiest way to contact me for everything, like stickers and not only, more stuff that I can help you with on my Twitter down the road. Conveniently, it's on the bottom of every slide. So if you are still not convinced you need to follow me, you will have the opportunity to do it later today. The most important slide of this talk is this. If you go to jfrog.com/show notes, you'll find there a page dedicated to this very meetup, and it already has the slides. It will have the video once Steve will share it with me. He's recording, so we will be able to post the video there very, very fast. All the links, including to the DORA report that I mentioned earlier, and everything else that is more to come, everything is there, so you don't need to take pictures or screenshots of slides or anything. Everything is in the show notes. Place to comment, to rate, and the raffle that Ari mentioned earlier. It's actually everybody wins a raffle. You can win the Nintendo Switch that he mentioned, but in any way, you will get an amazing JFrog t-shirt. So yeah, if you forget what is the URL, it's also on the bottom of every page. So this is convenient as well. So yeah, I hope I convinced you by now that we want to update faster. And let's take an example of someone who wanted to update faster. So meet Mark Reinhold. He is the chief of Java platform in Oracle, basically the most important Java person in the world. And 3 years ago, he decided that Java needs to move faster. It was the age of Java 8 back then, and there was a very big delay of adoption of Java, of development of Java 8. It took them like 3 or 4 years to get this version out of the door, and they decided no more. Now we're going to release faster because this is what the market demands. Every half a year, no matter what, new version of Java, new features, obviously better security, win-win, let's do it. That was 2017, Java 8 was out there, and then we had Java 9, Java 10, Java 11, Java 12, Java 13, Java 14, 7 versions later, we look at the situation in the market by reading the New Relic report of instrumented Java virtual machines in production in the world. And we can see that most of the Java virtual machines running in the world are Java 8. Not only most, more than 80% of Java virtual machines in the world are Java 8. And then you go like, what happened? Didn't Baruch just convince us how important Java updates are? So software updates are. So why no one updates their Java? And the answer is in the process of how do we update. Let's look at that for a second. So there is update available, and then we should decide whether we want it or not. Sometimes we just don't want it. There is nothing interesting in it. It's like Java 9, it's no, I don't want it. But sometimes we do want it. And the next question would be, are there high risks? If the answer is no, well, let's update. When the new version of Java is out, I'm going to install it on my machine. I'm going to update my own Java because the risks are very low. It's on my machine. There is nothing that I impact if something is broken. So yes, I will update because why not? But for my production servers, there are high risks. The next question is, do we trust the update? And trusting the update basically means I will install it on where there is a high risk because I know that the vendor won't break anything. And unfortunately, in our today's world, there are almost no vendors that we can trust their updates blindly. Unfortunately, not even JFrog, although we strive to be this vendor that you can trust. It's just hard. We're going to talk about why. Right? So if we trust, that's fine. If not, let's ask why. We can assume that people forgot how to test software. Back in the day, we knew how to test. We trusted our updates. No more. This is ridiculous. Obviously, our testing procedures are getting better, not worse. So what is the problem? One of the answers is complexity, and the other is data. Complexity basically means we have now microservices, which we have for very good reasons, but in the end of the day, it adds significant complexity, and our trust in the quality of our production declines. And also the sheer amount of data makes it very, very hard to test everything. So this is a study done by Seagate. They have obviously their reasons for showing high numbers. They sell hard drives and storage solutions, but still 175 zettabytes, it's completely mind-blowing. Just because zettabytes is a lot. What you think as a big data now, that will be petabytes probably, is after petabytes, there is exabytes. And after exabytes, there is zettabytes. It's really, really a lot of data. And the more companies we have that have more and more data, the harder it is for those companies to organize tests that can verify everything before they go to production. So this is why it's harder for us to trust our software. And sometimes if it will take for me now half a year to verify my Java update, and Java updates are out every half a year, I will skip some versions. I will say, well, I'll wait for the next one. I don't want to update this one. The problem is that if I skip the versions, next time I will have to check 2 updates, and the time-consuming verification gets larger and larger, the time that and the money that I need to spend in order to verify more and more updates. And this drives the vendors to go to the opposite direction, to say, you know what, I will defer the release of a new version until I have enough food on the table, until my release notes are sexy enough for people to take them regardless of the acceptance test that they need to do. So we have a trade-off, a very problematic trade-off of features that we really want and acceptance test costs. And the solution that the vendors take actually introduce a downward spiral that harms all of us. What I mean by that is that the less we have trust in updates, the more features the vendors pack in those updates, and the bigger and the rarer the updates become. And once they become bigger and rarer, we have even less trust in those updates because we know it will be even more expensive for us to test them, and then it goes and continues. So this is a very problematic trend that takes us away from frequently updated software. And as I started with, that's a very, very wrong direction to go. So let's talk a little bit of what can go wrong during those updates and how we as software vendors can improve this situation by providing more trustworthy software. So here is the first example. And the first example is Google no less. I start very, very high. The one before previous generation of great Google routers was called the Google On Hub. And that was one of the first routers that get updates over the year. Now, there is a huge problem with updates in entire IoT and especially in routers. In the recent study that I saw, where 170 models of the leading routers was compared, the average time of firmware between updates was more than 1 year. And this is an issue not only because the features, well, what features do you want from a router? It just works, but mostly from security perspective. If today we have a security breach, the attackers have an entire year to sit on your network and do whatever they do with it until you will patch your software and make it safe again. And this is what Google tried to solve with On Hub. It was a self-improving system, which means it gets updates over there. Yes, in the 7 years that On Hub been on the market, there were some feature improvements as well. One of them was how it's called, downtime. And this is where you can kind of announce that no Wi-Fi is available and people need to do stuff other than looking at their screens. The other was controlling lights, hue lights and what's not through the router. But basically what we usually get through those updates are security patches, very important. So 3 years ago, I was on a business trip when we actually went to the airport, into the planes and flew in the sky like birds. It was amazing. And I was on one of those and my wife is calling me and she's like, Baruch, the kids are sitting in the dark. I came home and the kids are in the dark. And I'm like, what happened? Do we have like a power outage? And she's like, no, the internet is down. And they shout, Alexa, turn on the lights, Alexa, turn on the lights, and nothing happens. So this day they learned that there are physical switches on the wall, but also we went to troubleshoot what happened with the internet. And we call our provider and they're like, no, we're fine. And then I get this email from Google that says, well, sorry, folks, we managed to reset your device with the latest update to default settings. And now we have no way to fix it because your router is not connected to the internet anymore. So please go ahead and reset up it manually to the previous state. Now, this is a big and common problem. With routers, it has limited impact because in the end of the day, I can go to my router in my living room and reset it up. It's not a big deal, but think about other devices. Think about, for example, a solar array somewhere in Sahara Desert that you need to fly 3 days in the helicopter and then ride 3 days in camels in order to get to it. That's a lot of money wasted. So sometimes update went catastrophically wrong and the over-the-air patch cannot reach the device. What is the solution? Well, local rollback. You have a previous version saved on the device and then roll it back. Now, the thing is, we know this concept at least for 25 years by now, since Windows 95. Because if you remember, when you replace your video card on your computer or you buy a new monitor and you change the resolution, what do you see? This is local rollback. It means that if you cannot access the device, if the screen is black because the resolution won't fit, then you will have automatic rollback in 8 seconds to the previous settings, which will fix the problem. So this is local rollback. We have it for years. Why we don't use it for stuff like routers? It's an open question. And frankly, this excuse, well, if we fuck up something, we cannot unfuck it over the air. This is one of the excuses why routers don't do over the air update. And you see the fix in front of your eyes. It's there, it's simple. So just use it and don't use it as an excuse for not doing updates. And then you can say, well, this is IoT. I'm not an IoT developer. I don't care about this stuff. Well, you do, because the T in IoT, the things, stands for all the things, including your servers, including your cloud, including whatever you're working is. Software is software is software. And let's talk about IoT. I like this topic. How about self-updating cars? Self-updating cars are fun, and here's an example of a great self-updating car, Jaguar I-Pace. It was released in the beginning of last year, and then in the middle of last year, 6 months after it was released, we discovered that there is a bug in the brakes. Ouch, software bug in the brakes. Pretty important. What do? Well, if you don't have over-the-air update, you do a recall. And the problem with recall is that recalls suck. Recall sucks because first of all, it's very expensive because you have to have all those services line up to service the cars. And it also sucks because you don't have any way to force the driver to do the recall. What are you going to do? You're going to call them and get filtered. You're going to send them an email that will go to spam, and you're going to send them a physical mail in the red envelope with caps letters important recall that will go in the recycled trash bin. So frankly, recalls suck, and you really don't need it for software because you can update software over the air. If you do it over the air, you can force the updates on everybody, and it's actually much cheaper. The only thing better than continuous updates, than over-the-air updates, are continuous over-the-air updates. And the difference between updates and continuous updates can be shown in another great car, Tesla. Now, Tesla is an amazing car, but it has one nasty bug that will probably go away once the autopilot will get smarter, but for now it's with us, and it's called phantom braking. Phantom braking is when you drive on a highway, it's a sunny day, there are no problems, and suddenly, boom, the car smashes on the brakes. It's really annoying for you, annoying for the family. Worst thing is no one will ever believe that autopilot did that and not the driver, so you get blamed for lousy driving. There was a rumor there is a fix for phantom braking, and all the drivers went like, yoo-hoo, we're going to get rid of it finally. And then the update didn't come, and it didn't come and didn't come. And eventually when it came, the drivers discovered why it was delayed so much. It was delayed so much because of chess. What does it mean because of chess? Well, in the release that have these minor improvements and bug fixes that fix the phantom braking, there was the big feature was chess game. And it's important for Tesla drivers because this is what they play when they charge their car and supercharger. And don't get me wrong, chess is great, but waiting for chess in order to fix the phantom braking, that sounds ridiculous. Why would you wait for such a non-important feature? From the other side, I apologize. From the other side, maybe you are smart and then you don't use the half-baked autopilot. Instead, you play chess because you're smart. And then you wait for chess to come out because you heard the rumor that next version will include chess that you can play while charging the car. And the update won't come, and when it comes, it turns out that you waited for your chess because there was, people were working on this phantom braking thing that you don't even use. What I want to say here is that when you do bulk updates or updates in batches, you actually group important updates and not important updates. And what I just illustrated is that what is important and what is not important is in the eye of the beholder and cannot be prioritized in a lot of cases. So instead of prioritizing what should be released, what can wait for what, don't do that. Just release once you have it. And then the chess players will get what important for them as soon as possible, and the autopilot drivers will get what's important for them as soon as possible, and that's obviously a win-win. It also, just to remind you, simplifies the update and builds the trust because you have less things to check in your acceptance checks, if at all. If we break the updates to the pieces so small and simple that we can say, well, this is trivial, well, just do it. Here you go. This is where we recreated the trust that I spoke about. Now let's go to the server side. This is a relatively old story. It's from 8 years ago, but still mind-blowing, and I really love to talk about that. Knight Capital, a trading firm, electronic trading firm from Wall Street, managed a relatively big asset portfolio, about $600 million. And after years with their old trading system, they decided to update. And everything went wrong. They, well, first of all, it was a decision that they are going to reuse some old APIs. And now the old APIs do something completely different, like sell instead of buy or something that different. And then they just forgot to update one of their 8 servers just because they never did it. So they kind of forgot about it. Oops. And then new clients sent requests to machine-contained old code. And when they discovered that this is happening because they started losing money, they kind of, oh, okay, something happened during the update. Let's roll back all the update. And when they rolled back all the updates, all the new clients were corresponding with their old APIs, and basically over the next 40 minutes, they lost $440 million, went bankrupt, never recovered from it. They didn't have any monitoring, any alerting, any debugging. All that happened live. All the debugging happened live on the production system, and that was obviously a disaster. And there are tons of stuff to learn from Knight Capital. And again, in the last 8 years, industry did a great job in learning some of them. And let me just reiterate what we can learn. So first of all, automated deployment. People suck at repetitive tasks. It's normal for people to forget to update one of 8 servers. Machines never do that. So automating everything provides higher quality than relying on people. Also, once you update once in a few years, probably no one in your team has any idea what to do. And even those who did it many years ago don't have the habit or the skill to implement it successfully. Anxiety is ramping high. Everybody's palms are wet. Everybody are nervous. This brings mistakes. Instead, if it hurts, do it more. The mantra, one of the most important mantras of DevOps, if it hurts, do it more, fits here like a glove. If you update faster, if you update more frequently, you will develop skill and habit. And this goes back to all the other benefits of frequent updates like security and features. Here's another one. Update won't be something that is scary and unknown for you if you update frequently enough. State awareness. They decided they reuse all the APIs. Well, questionable decision, but okay. What you need to know is how it's going to affect it and what you need to do when things go wrong. And this is obviously something that they thought about it much less. Another, and I think that's the last one, another example is CloudFlare in the middle of last year. You might remember how big chunks of internet went down for 30 minutes because they used CloudFlare. And what happened? Well, CloudFlare deploys rules to battle attacks, DDoS attacks, and different types of attacks. And usually those rules are configured using regular expressions. And this time they managed to deploy a single misconfigured rule. Now, what happened next actually made me sure that this world is going to end not because of the coronavirus, not because of the global warming, and not because of the giant asteroid that's going to crash the Earth. Instead, it will be a single misconfigured regular expression, because that's exactly what happened. They deployed a misconfigured regular expression. It's caused the CPU to spike to 100%. And then obviously when redundancy and elasticity kicked in, they managed to bring the entire CPUs of all their data centers to 100%. And the next thing you know, the update on their status page literally said affected region Earth, which is very true. And the thing that I don't really understand how it happened is how we ended up with affected region Earth. Just because CloudFlare is a very progressive company and they know exactly what progressive delivery is. Progressive delivery is protecting us against hitting all the users at once with a bug. Instead, we release to a small number of users and then we observe. This is how we reduce the blast radius. And if the problem occurs, we stop the release, we revert the update for the affected users. This is in 2020 and even in 2019 is pretty basic stuff for software updates. And if they didn't do it, they should. If you didn't do it, if you don't do it, you should. And again, this is concept that we know since we were 8, since our parents taught us how to do laundry. Look at the warning of every detergent or fabric treatment solution. It always said, always spot test on hidden service first. This is progressive delivery. You try on a small piece of fabric, and if it's okay, you release it to all the users. If not, you revert it. In this case, it's not reversible, so you just throw the small piece of fabric away, but it's the same concept. Very familiar from real life. We need to do it more in software updates. Progressive delivery has to come with observability because you need to know when things go wrong. Relying on people shouting on you on Twitter is obviously damaging to your reputation and not nice, but also won't provide you the needed data. Instead, you implement tracing and logging and monitoring, and basically you can go all the way to automatically observe your canary deployments and automatically log them, revert them back if anything went wrong. And the rollback is obviously the solution, because when fixes might take time, it takes you time to figure out what went wrong. In the meanwhile, revert to a previous version without delay and make your users, although on a previous version, but on a working version, happy. Now, some platforms just don't support rollback. For example, all the mobile platforms, and this is astonishing, in 2020, both in Apple App Store and Google Play Store, if you want to roll back to a previous version that was already approved by Google or Apple, you cannot do that. You can take the previous file and you can try to deploy it, but you need to rename it to the next version, submit it for review as it was the next version, and after review is done, you can deploy it. There is no way to say to Apple and to Google, hey, you already reviewed it. It's a previous version from 2 days ago. Just deploy it to production because people are suffering. There is no way to do it. So instead, what you can do is feature flags. You can embed 2 versions of the features in the app and trigger them with API calls, or you can just kind of make the new feature go away. If you added like a button, you can just remove it and make it disappear, or something like that using REST API. And then you are not dependent on the ability of the platform to do rollback. So with that, what we will have if we do all those tricks. So update is available. Do we want it? Yes or no, it doesn't matter, because we have automatic updates. And we have automatic updates because if there are no high risks, there is no reason not to update. But even if there are high risks, we build a trust between us, the vendors, and the users of our software, the trust that allow us to say, well, hell yes, let's update anyway, because nothing will go wrong. And if it will, our vendor will know how to deal with it before we even notice. So our goal is to transition from bulk and rare software updates to extremely tiny and extremely frequent software updates. So tiny and so frequent that they provide an illusion of software flowing from development to update target. We call it the liquid software version because of the flowing illusion that we want to achieve. And 2 co-authors of JFrog, Yoav Landman and friend Simon, and yours truly, we wrote a book about it calling The Liquid Software, How to Achieve Trusted Continuous Updates in the DevOps World. And remember how I mentioned you will need my Twitter handle? This is where you need it. If you want this book, you can direct message me on Twitter at jbaruch, it's right here, and I will ship you a hard copy of the book. Once you provide me with your shipping address, again, as a small thank you of being here, hearing about liquid software, and hopefully assessing what it will take to switch to it in the software that you write. Before we end up, I want to talk a little bit about corner cases. You might think, well, it's a nice idea for whatever CloudFlare and what's not, but there are obviously some corner cases when automatic updates and anytime won't work. And obviously there are, I'm not going to claim that there aren't, but they are much much more rare cases that you might expect. And I will give you a very, very extreme example. How about updating a plane mid-air? So Airbus A350 has a memory leak. It needs to be restarted every 150 hours. And if you think that this is something unique to this model, here is another example. Boeing 787 has a register leak and needs to be restarted every 51 days. Those problems are very significant. There are protocols on how to check that you didn't forget to restart your plane before you take off. Well, let's agree it's not the best solution. It's not the best solution because, as I want to remind you, people suck at repetitive tasks. And let's say we just forgot to reboot our plane. And now we are mid-air, and the dilemma is fixing the memory leak mid-air with continuous updates and liquid software, or God knows what happened. Another example might be more theoretical. This is super practical, but more theoretical. You know how all the infotainments run Linux behind the scenes? Let's say someone managed to hack into infotainment system and from there go into the navigation system and now threatening the health of and the lives of everybody on the plane. Would it be nice to patch this security vulnerability with liquid software mid-plane? I think it could be. The good news are these already have been done. During the development of 777, and that's the first plane that was completely software driven. It's like Tesla for the cars, but 30 years ago, fly by wire. Everything is, nothing is mechanical anymore. They had a problem with stabilization under turbulence. What they did, they took all the software engineers, all the developers, put them on a plane, took off, went to the area of turbulence, find the bug, debug mid-flight, find the bug, fix the bug, and patched the system mid-flight to verify that it actually works. All that, this is liquid software in action. So it has been done for the airplanes mid-plane, mid-flight, and it was a good idea then, still a good idea now. So with that, Q&A and Twitter ads, @JBaruch on Twitter, ping me for anything, including if you want a book, hashtag liquid software. When you go on to say something about this talk, please don't forget this hashtag, DevOps TO. I hope there is a real thing. I just it, but I hope it actually matches the real hashtag. And liquidsoftware.com, this is where you go to learn more about the book. Don't forget the jeffrog.com show notes, the slides, all the links for everything, including all the stories, including the stories about the planes, everything is there. Place to comment and rate, and the prices that Ari brings to you. This is the QR code that you can scan now and get to the page directly. Monthly drawing for a Nintendo Switch, and everybody win a t-shirt by just entering the raffle. So with that, thank you very much.
Well, thanks very much, Baruch. That was great. I will give everybody a second to jump in with some questions.
Please
but I always have a question. Like, my go-to question to learn more about anything is like, how do you get started with this? How can you experiment with something like continuous updates or the idea of liquid software?
So this is a great question, and the good news about it is that it's not a flip of a switch. Mm-hmm. We spoke about some of the practices, and there are obviously more illustrated in the book that you can adopt step by step, one after another. You start doing more automatic testing, and then you start doing progressive delivery, and then you start doing local rollbacks. And every step on the way, you build this trust. And it's also obviously building trust takes time from the situation when you go like, well, it will take me half a year to check your software. And this is why I will defer updates as much as possible, to the situation when, well, yeah, we get updates every couple hours from them, and they're always been fine. It's obviously two extremes, that there is a whole range and a very long time before this can happen. So for me, once you start adopting those techniques for various reasons, the liquid software might even not be your end goal. In the end of the day, we are moving the industry, and you move your organization in the right direction towards smaller, more frequent, and more trustworthy updates.